So today we're doing a lesson on chance experiments with outcomes that are not equally likely. So we're going to be looking at things with probabilities where the chances of something happening is not equal to the chance of something else happening. So outcomes that are not equally likely to each other. So we'll just jump into a couple problems right away and look at how to do them. So looking at this example right here, it says Jenna's husband Rick is concerned about his diet. On any given day, he eats 0, 1, 2, 3, or 4 servings of fruits and vegetables. The probabilities are given in the table below. So here you can see the probability of him eating 0 apples is 0.08, which remember is equivalent to 8%. The probability of eating 1 apple is 0.13, which is 13%. The number of servings of fruits and vegetables, if it's 2, the chance of that happening is 0.28, which is the same as 28%, and so on for the other two. So again, you could view them as percents or decimals. Either one is fine. Sometimes in different problems you'll see it as decimals, sometimes you see it as percents. It's just good to know that you can use it as both. Okay, so the question here, we have 3 questions about it, about the table. It says, number 1, on a given day, find the probability that Rick eats 2 servings of fruits and vegetables. So here, all you have to do is look at the table. The probability that he eats 2 servings is right there. The probability that he eats 2 servings is 0.28. Or 28%. Again, same thing. Let's see. Let's look at B. The probability that Rick eats more than 2 servings of fruits and vegetables. So you got to think of keyword more than 2. What does more than 2 mean? It means anything greater than 2, right? So what's the probability that he eats greater than 2? So if he eats greater than 2 servings of fruits and vegetables, that means he eats 3 or 4, right? So the probability of him eating more than 2, you would have to add these 2 probabilities together. So you do 0.39 is the probability that he eats 3 servings, plus 0.42 is the probability that he eats 4 servings. You add that up together, you get 0.81 or 81%. Alright, who caught my mistake? Hopefully some of you guys did. Just looking there, I accidentally wrote 0.42 for 4 servings. That's not 0.42, it's 0.12. Right? So let's go back a little bit, erase these. Again, jumping back, it says, what's the probability that he eats more than 2 servings? So that's 3 servings or 4 servings. So I write down the probability for 3 servings is 0.39, and the probability for 4 servings is 0.12. So you add those 2 together, you get 0.51 or 51%. Okay, good. So then looking at C, what's the probability that Rick eats at least 2 servings? So at least 2 servings of fruits and vegetables. So let's think about what does the phrase at least mean? So here, at least 2 servings means he eats 2 or more, right? That's what at least means. So that means he can eat 2 servings. Here, I'm going to erase my answer for part B just so that part C could be easier to read it. So at least 2 servings means he eats 2, 3, or 4, right? So again, the probability he eats 2 is 0.28. The probability he eats 3 is 0.39. The probability that he eats 4 is 0.12. So you would need to add all these decimals up together to figure out the probability that he eats at least 2 servings. And you've added those, you get 0.79 or 79%. So that's the probability of him eating 2 or more, aka at least 2. Okay, so actually we could look at question 2 also. It says find the probability that Rick does not eat exactly 2 servings of fruits and vegetables. So they want us to figure out what's the chance that he does not eat. So keyword here, pay attention to that. Does not eat exactly 2. So what we should know about all these probability tables, of all the possible outcomes, they should always add up to 1 or 100%. That should be the case for all of these. So you add all of the outcomes. I want you guys to check it yourselves. Add all these probabilities, you should get 1 or 100%, right? Because there's a 100% chance that one of these things will happen. But they're asking what's the probability that he does not eat exactly 2. So we know the probability that he eats exactly 2 is 0.28, right? What we could do here is we could just do the whole thing and then deduct. Here, let me write that with a red marker. And we could deduct the probability that he eats 2. So the probability that of anything happening is 1, but the probability of him eating exactly 2 is 0.28. So you could do 1, take away 0.28 here, and then you get 0.72 or 72%. So it's a 72% chance that he does not eat exactly 2. Alright, we'll look at another example here. We'll look down here about another example about vegetables. Here it says, let's see. When Jenna goes to the farmer's market, she also usually buys some broccoli. The possible number of heads of broccoli that she buys and the probabilities are given in the table below. So same thing. So we'll look at this table and then we're gonna answer the questions. So here we know that she's either gonna buy 0 heads of broccoli, 1, 2, 3, or 4, and the probabilities here are listed below. It's pretty much the same as the other one, except the probabilities are listed as fractions. Remember, probabilities can be written as fractions, decimals, or percents. So here they're written as fractions. So, question A, find the probability that Jenna buys exactly 3 heads of broccoli. Here, just look at the table. The probability that she buys exactly 3 is just 1/4. And question B says, find the probability that Jenna does not buy exactly 3 heads of broccoli. So again, just like in the other problem, all these probabilities of all the possible outcomes should equal to 1. And if you add all those up, you will get 1. Because there's a 100% chance that one of these things is happening. So if the probability that she eats or that she buys 3 broccoli heads is 1/4, right here I can simply do 1 whole, subtract 1/4 to figure out the probability that she does not buy 3 heads. And here you could do this in your head if you know that 1 take away 1/4 is just 3/4, or if you want, we can have common denominators. You could think of 1 as 4/4. Subtract 1/4 is 3/4. Okay, so looking at question C. Find the probability that Jenna buys more than 1 head of broccoli. So more than 1 head means anything greater than 1, right? So that means that would include 2 broccoli heads, 3 broccoli heads, or 4. So that means you add those values together to figure out the probability of her buying more than one. So the probability of her buying 2 broccoli heads is 5/12. The probability of her buying 3 broccolis is 1/4. And the probability of her buying 4 broccoli heads is 1/12. These are all more than 1. So let me erase part of B here so we have a little bit extra room. So if you remember to add fractions, just before we got to get a common denominator. Here, the number that can go into 12, 4, and 12 is just 12, right? Because 4 goes into 12 3 times. So what I could do here is multiply the numerator and denominator by 3. So we get the first one stays the same. The second fraction becomes 3/12, and the third one becomes 1/12. And we can just add all this together. We get 5 plus 3 is 8, plus 1 is 9. So we get 9/12. Or I can simplify that to be 3/4. Alright, last one. So the probability for buying at least 3 broccoli heads. So again, let's think about what does at least 3 mean. At least 3 means 3 or more. So that includes these 2 boxes up here. Let me do that now. These 2. 3 or more would be 3 or 4 in this case. Could be 5 also, but there's no 5 or 6 up here. Alright. So simply here, we just need to add the probability of her buying 3 would be 1/4. But again, it's at least 3, which is 3 or more. So you got to add the probability of buying 4, which is 1/12. So we need to add those 2 fractions. But again, here I can multiply the first fraction by 3/3 to get a common denominator of 12. If we add those together, we get 4/12, which simplifies to be 1/3. So that means the probability of her buying at least 3 broccoli heads is 1/3. So hopefully that isn't too bad. Really, we're just adding the probabilities of different events together.